The European Centre for Particle Research, CERN, is unveiling details of a new particle accelerator today.
Huge tunnel, over 100 meters underground and 27 kilometers long.
Well, first of all, it is a Big Bang model. In other words, there is a Big Bang, but the Big Bang was not the beginning.
In the center of Geneva, Switzerland, the European Organization for Nuclear Research, CERN, has just unraveled a terrifying mystery about our universe that scientists cannot yet explain. And rather unexpectedly, Roger Penrose, a renowned scientist who's been outside the radar for the longest time, has just stepped forward and revealed shocking details about the latest discovery by CERN. What does this discovery mean for our understanding of the universe? And how does it relate to the Mandela Effect, as many experts are already pointing at? Join us on this compelling journey as we unravel how something very evil just happened at CERN that no one can explain. The phenomenal legacy of Roger Penrose. Few guests who appear on Joe Rogan's podcast carry as much weight as Sir Roger Penrose. He's like a superstar in both math and physics, known for his mind-blowing discoveries. Penrose has had an incredible career filled with remarkable accomplishments. One of the biggest feathers in his cap is winning the Nobel Prize in Physics.
Roger Penrose receiving one half of this year's Nobel Prize
for his groundbreaking work on black holes. His research on these mysterious cosmic entities confirmed what Einstein's theory of relativity had predicted about them. But Penrose didn't stop there. He teamed up with the legendary Stephen Hawking to develop what's known as the Penrose-Hawking singularity theorems. These theorems provided a mathematical foundation for understanding singularities and the event horizon, the point of no return around a black hole. Their collaboration opened up new avenues of understanding about space-time. For his contributions, Penrose was honored with the prestigious Wolf Prize in Physics. Penrose's brilliance extends beyond the cosmos. He's also co-developed the Penrose inverse, a concept critical in algebra with applications in various scientific fields. Another feather in his cap is the Penrose tiling, a pattern that continues to baffle mathematicians and inspire artists. This scientific titan has been recognized with the highest honors in his field, including the Copley Medal from the Royal Society. He's also received other esteemed awards like the Eddington Medal, the Royal Medal, and even the Albert Einstein Medal. Penrose's theoretical work has served as the foundation for numerous experimental pursuits, particularly at CERN, where scientists delve into the mysteries of fundamental particles and forces. For instance, CERN's Large Hadron Collider measures scattering amplitudes, which are closely linked to abstract ideas formulated by Penrose. One of Penrose's intriguing theories is the orchestrated objective reduction, ORCOR theory, which suggests that quantum processes play a role in the development of consciousness. This theory connects the realms of physics and philosophy of mind, delving into profound questions about the nature of consciousness. Penrose has also delved into cosmology with his theory of conformal cyclic cosmology, which proposes a cyclical view of the universe. According to this theory, each iteration or eon of the universe begins with a Big Bang, offering a fresh perspective on the origins of everything. CERN, the European Organization for Nuclear Research, founded in 1954, stands as a beacon of scientific exploration. Its mission is to uncover the deepest secrets of the universe. One of CERN's most significant achievements was the discovery of the Higgs boson particle, a quest that many researchers devoted their lives to. However, the breakthrough eventually came, shedding light on one of the most elusive particles in physics. CERN's contributions to our understanding of the universe are monumental, and its ongoing research continues to push the boundaries of human knowledge. The enchanting expedition of CERN. Deep within the heart of CERN's pioneering work lies a fascinating journey to rewind time itself and explore the moments just after the massive explosion known as the Big Bang. But how do they embark on such a monumental quest? Let us look at the Large Hadron Collider LHC. This colossal machine accelerates particles to speeds approaching that of light before smashing them together, recreating the energetic conditions of the early universe. This collision provides scientists with a unique window into the universe's beginnings. Yet, within this scientific marvel, a baffling revelation has emerged, leaving even the most clever minds astonished. What has been unearthed And why does it leave the scientific community in awe? The story of CERN and its LHC unfolds like an epic tale, woven through the annals of history. Situated on the outskirts of Geneva, CERN arose from the aftermath of World War II, driven by a noble ambition to wield science as a force for peace, uniting nations in a shared pursuit of unraveling the mysteries of the cosmos. From humble beginnings with 12 founding members, CERN developed into a global institution, beckoning nations from across the globe to join its scholarly adventure. This spirit of international solidarity has been the cornerstone of CERN's achievements, fostering an environment where brilliance transcends borders and unity eclipses political divisions. The construction of the LHC symbolized human creativity on an extraordinary scale. A collaborative effort of scientists, engineers, and technicians from around the world brought this bold vision to fulfillment, marked by feats of engineering prowess and groundbreaking advancements in magnetism, vacuum technology, and computational prowess. The LHC, a titan of scientific innovation, snakes beneath the Swiss countryside like a subterranean behemoth. Its 27-kilometer circumference and subterranean lair represented a fusion of precision and ambition. Within its hollow depths, particles race towards a collision, echoing the devastating events of the universe's dawn. But why embark on this cosmic journey? The answer lies in the profound implications of these mini-Big Bangs. By scrutinizing the aftermath of these high-energy collisions, scientists unravel the ancient design of cosmic evolution, piecing together the very fabric of existence itself. This knowledge holds the key to unlocking fundamental questions about the nature of matter, the workings of energy, and the universal laws that govern our cosmos. CERN's endeavors provide a glimpse into the past, offering insights into the fundamental principles of the universe. This understanding has the potential to spawn revolutionary technologies and concepts that could reshape the future of humanity. In 2012, scientists at CERN made a groundbreaking discovery, the Higgs boson. Named the God particle, this elusive particle plays a pivotal role in explaining the fundamental forces of the universe. Imagine the universe as a vast ocean, with particles likened to tiny boats navigating its depths. The Higgs boson serves as the water in this metaphorical sea, endowing particles with mass and shaping the very fabric of reality. Without the Higgs boson, particles would careen through space at incredible speeds, devoid of substance, incapable of forming the celestial bodies that populate our universe. However, the Higgs boson's properties have presented scientists with perplexing secrets. Its observed mass deviates from theoretical predictions, giving rise to what is known as the hierarchy problem. This discrepancy suggests the existence of undiscovered particles or forces lurking beyond the confines of current scientific understanding. These mysterious entities may hold the key to unraveling the mysteries surrounding the Higgs boson's elusive nature and shedding light on the conditions prevailing in the universe's infancy. Moreover, the Higgs boson serves as a portal to the ancient period of the universe, offering insights into the formative stages of cosmic evolution. Understanding its properties could provide invaluable clues regarding the emergence of mass and the intricate interplay of fundamental forces during the universe's formative stages. This knowledge not only deepens our comprehension of cosmic history, but also sheds light on the underlying mechanisms driving the universe's evolution over billions of years. Yet, as scientists delve deeper into the mysteries of the Higgs boson, they have encountered phenomena that defy conventional explanations. Enter dark matter, a mysterious substance that penetrates the cosmos, exerting gravitational influence yet evading direct detection. The discovery of the Higgs boson unveiled the existence of the Higgs field, an invisible energy field that infuses the universe, interacting with particles and endowing them with mass. However, this revelation has unveiled an abundance of unanswered questions, opening new avenues of inquiry into the nature of dark matter and its role in shaping the cosmos. In essence, CERN's pursuit of scientific knowledge transcends the boundaries of human understanding, unraveling the mysteries of the universe while simultaneously giving rise to new secrets. The quest to unravel the fundamental laws governing our reality continues persistently, fueled by curiosity, collaboration, and the insatiable desire to unlock the secrets of existence itself. These findings unveil numerous fresh mysteries to explore. CERN's quest to uncover dark matter. Dark matter is like the universe's biggest mystery puzzle. Even though it's a huge part of everything in the universe, making up about 85%, we can't see it at all. It's like a ghost, not giving off any light or bouncing light off it, so it's invisible. We only know it exists because of how it pulls on other things with its gravity. This mysterious stuff is super important because it's like the invisible force that shapes how galaxies and the whole universe stick together. So, where does CERN fit into all of this? Well, they're on a mission to uncover the secrets of dark matter using their fancy machine, the Large Hadron Collider. This big machine smashes particles together at crazy speeds, recreating the wild moments right after the Big Bang. By studying the bits and pieces that fly out of these collisions, scientists hope to catch a glimpse of dark matter particles. But here's the tricky part. Dark matter is super sneaky. It doesn't play nice with light or any other kind of radiation, so we can't just look for it like we do with other things in the universe. But if these dark matter particles do exist, sometimes they might interact with other particles that the collider can see. So, scientists are keeping their eyes peeled for any signs, like bits of energy or momentum that seem to vanish into thin air after a collision. That could be our clue that dark matter is slipping through our fingers, unseen but still leaving a trace. CERN's experiments are like detectives, gathering clues from smashing particles together to understand dark matter better. Although they haven't directly spotted dark matter yet, the collider's superpower is it can explore the tiniest bits of the universe. This helps scientists figure out what dark matter might be and how it shapes the world around us. But there's a shadow of risk lurking in CERN's quest to uncover dark matter. By shining a light on this mysterious substance, could they be unlocking something dangerous for our world? Anatoly Bugorsky, a Russian physicist, encountered something straight out of a science fiction tale. It all happened in 1978 while Bugorsky was working on a particle accelerator in Russia. As he leaned in to check on a malfunction, a proton beam zapped right through his head. In an instant, he saw a blinding flash brighter than 1,000 suns, yet felt no pain. The beam entered through the back of his head and exited near his nose, leaving behind a path of destruction. His face swelled, and in the following days, the skin peeled off where the beam had passed, revealing the trail it had scorched through parts of his brain. Miraculously, Bugorsky survived the ordeal, but not without consequences. He lost hearing in one ear, and the left side of his face remained paralyzed. Over time, he battled seizures and other neurological issues. Despite the harrowing experience, Bugorsky continued his scientific pursuits, even completing his PhD. The Bugorsky incident shows just how powerful particle accelerators can be. These machines are built to explore the secrets of the universe, but they pack a lot of energy and can be dangerous, if not handled carefully. But aside from safety considerations, there's also anticipation surrounding what CERN's experiments could reveal. Exploring dimensions and the Mandela Effect. One interesting area of study is the concept of other dimensions. It might sound like something from a science fiction story, but it's a serious topic in physics. The idea is that our universe might be just one of many in a huge multiverse, each with its own set of rules. So, how might CERN's experiments reveal these hidden dimensions? It all comes down to the Large Hadron Collider and its powerful collisions of particles. Some scientists think that under these extreme conditions, we might see signs of dimensions beyond our usual three-dimensional space. For example, particles might disappear into these other dimensions, leaving behind a special energy signature. Gravity, which is weaker than other forces, might be leaking into these dimensions, which could explain why it's so weak compared to forces like electromagnetism. Discovering other dimensions could completely change how we see the universe. It could support ideas like string theory, which suggests that particles are tiny vibrating strings connecting our universe to others. Moreover, finding other dimensions could help solve big mysteries in physics, like what dark matter is and how the basic forces work. If dark matter interacts more in these other dimensions, it could explain why it's so hard to detect. So, while the idea of other dimensions might sound like a wild guess, it's a serious area of research for scientists at CERN. It's a quest to answer big questions about how the world works. Even though the idea of a multiverse might sound like something from a fairy tale, it's based on real science. Scientists use math and do experiments with a lot of energy to study it. As CERN keeps pushing the limits of what we know, we might discover that our universe is just one part of a much bigger and more complicated cosmos than we ever thought. But why are scientists so worried about what these theories of other dimensions might uncover? CERN's experiments with other dimensions have introduced us to a concept that used to be seen as just a wild idea. Have you ever been sure something happened one way, only to find out you were wrong? That's called the Mandela Effect. It's when lots of people remember things differently from how they happened. It got its name from Nelson Mandela, who many people incorrectly thought died in prison in the 1980s. The Mandela Effect has made a lot of people curious and started a lot of arguments. One famous example of the Mandela Effect is about the spelling of a popular kids' book series called The Berenstain Bears. Some people remember it being spelled with an E, like Berenstein, even though that's not how it's spelled. Another example is from the movie Snow White and the Seven Dwarfs. Many people remember the evil queen saying, "Mirror, mirror on the wall," but she says, "Magic mirror on the wall." These differences in what people remember have left a lot of folks confused and looking for answers. Some scientists think the Mandela Effect might be connected to the idea of parallel universes. They say maybe these false memories are from other realities that somehow mixed with our own. According to this idea, in some other universe, Nelson Mandela did die in prison. The Berenstain Bears was spelled with an E, and the line from Snow White was "Mirror, mirror on the wall." These memories might sneak into our world, causing the Mandela Effect. Another interesting example of the Mandela Effect comes from the famous line in the movie Star Wars: The Empire Strikes Back. Many fans remember a famous scene from Star Wars: The Empire Strikes Back, where Darth Vader tells Luke Skywalker, "Luke, I am your father." This line has become iconic, appearing in jokes, parodies, and references all over pop culture. However, when people go back and watch the movie again, they're surprised to find out that Darth Vader says, "No, I am your father." This mismatch between memory and reality is called the Mandela Effect. Some people think it's linked to the idea of other universes, where different versions of events might exist, but most psychologists and brain scientists think it's just our brains playing tricks on us. They say memory isn't like a video recording, it's more like a story we tell ourselves, and sometimes we get it wrong. So, where does CERN, the research center in Switzerland, come into this? Some people have controversial ideas that the experiments they do with their big machine, the Large Hadron Collider, could somehow mess with reality. They suggest that by recreating conditions similar to those just after the Big Bang, CERN might accidentally change things or even create new realities that mix with ours. But it's important to be skeptical about this theory. The Large Hadron Collider follows the rules of physics, and there's no evidence that it can change the past or create other universes. It's exciting to think about, but for now, it's just a wild idea. The experiments happening at CERN are super carefully planned and checked, with safety and ethics as the top priority. Unraveling Earth's magnetic mystery and technology. In 2022, during the third set of experiments with the Large Hadron Collider, something strange happened. There was a weird disturbance in Earth's magnetic field that caught everyone's attention. This anomaly lasted for a long time and was pretty intense. People started wondering if the super high-energy stuff happening in the collider had messed with Earth's magnetic shield and maybe opened a door to another universe. Earth's magnetic field acts like an invisible shield, protecting us from space stuff like solar winds and cosmic rays. When it gets messed up, it can cause big problems for things like satellites and our electrical systems. So, after this weird incident, a bunch of investigations started to figure out what was going on. Scientists from different fields teamed up to dig through all the data. First, they looked at what was happening in the collider at the time. They checked if any unusual experiments or events might explain the magnetic field hiccup. They also looked at the energy levels and the rate of particle collisions happening in the collider. At the same time, other scientists were checking out what the sun was up to. Solar flares and big solar explosions can mess with Earth's magnetic field, so they wanted to rule out any solar shenanigans. They also looked into geological stuff that might have caused the disturbance. It was like a big detective mission to figure out what caused the magnetic field to go unreliable. The Earth's insides, like the moving molten core, can mess with the magnetic field. Scientists dug into old data to see if anything similar happened before, which could help explain what went down in 2022. When the weird magnetic field thing happened, it got people thinking, could the big experiments we're doing mess with Earth's natural systems? It made everyone realize we need to keep an eye on things and do more research to keep our planet safe. Right now, scientists are still trying to figure out if there's a connection between what happened in the collider and the magnetic field goof-up. They're working hard to solve this mystery using super serious science. But for now, we're still in the dark about what caused the magnetic field hiccup. CERN's super cool experiments, especially with the Large Hadron Collider, are like exploring uncharted territories in the universe. But with this exploration comes big questions about ethics and our place in the universe. We're diving into areas of physics that we don't fully understand yet. What are the risks of going into these unknown realms? And how do we balance our thirst for knowledge with making sure we don't accidentally mess things up? Trying to figure out the tiniest bits and pieces of the universe is important, but as we get closer to recreating what the universe was like at the very beginning, we're stepping into unknown territory. People like theoretical physicist Sean Carroll talk about this a lot. He says it's super important to be curious, but also careful when we're doing science stuff. We need to think about what might happen if we discover something new. Discovering new particles, forces, or even dimensions is super exciting. But we also have to think about what might happen if things go wrong. Like, people worry that CERN's experiments could mess with Earth's magnetic field or open up portals to other dimensions. So it's not just about doing cool science, it's also about being responsible. We need to make sure we're following strict rules and thinking about the impact of what we're doing. And it's not just about the science itself. We also have to think about the big amounts of money and brain power that go into this research. Some people wonder if we should be putting all this effort into understanding the universe when there are more pressing problems here on Earth. However, according to Carroll and others, delving into fundamental science often brings about unexpected advantages that can address broader societal issues. Have the experiments conducted at CERN in the past resulted in benefits for our everyday lives? While CERN is mainly recognized for its exploration of the universe at the smallest levels, its impacts reach far beyond the realm of particle physics. The investigations carried out at this esteemed institution have led to practical applications that influence various aspects of our daily routines, especially in the fields of medicine and technology. One remarkable example of CERN's broader influence is in medical imaging. Technologies derived from particle detection methods used in experiments, like those conducted at the collider, have been adapted for medical purposes. For instance, advancements in particle detection technologies pioneered at CERN have improved positron emission tomography, PET, scans, and a crucial tool in modern medical diagnostics. These scans aid doctors in identifying cancer and monitoring heart and brain functions, demonstrating how research in high-energy physics can contribute to life-saving medical advancements. Furthermore, CERN's research has facilitated advancements in radiation therapy for cancer treatment. The understanding and technologies developed from particle acceleration and manipulation, areas where CERN leads globally, have led to the creation of more precise and effective forms of radiotherapy, such as proton beam therapy. This treatment method allows for the targeting of tumors with minimal damage to surrounding healthy tissues, representing a significant advancement in cancer care. CERN's impact on technology goes beyond medicine, with the invention of the World Wide Web by Sir Tim Berners-Lee in 1989 standing out as revolutionary. Originally designed for physicists to share information, the web has transformed global communication and knowledge access. Additionally, CERN's advancements in computing, particularly through distributed computing, like the worldwide Large Hadron Collider computing grid, have revolutionized data analysis in various fields such as climate research and bioinformatics. CERN's impact extends far beyond theoretical physics, demonstrating tangible benefits in medicine and technology. It's time for today's subscriber pick. Roger Penrose revealed something evil just happened at CERN that no one can explain. At the center of CERN, where scientists explore the unknown, a tense atmosphere fills the air. The huge accelerator buzzed with excitement until it suddenly stopped working. Screens flashed with confusing data, and the researchers panicked. Something had gone very wrong. Technicians rushed to find out what was happening, and worries spread quickly among the researchers. In the dark hallways, shadows seemed to move strangely. There was a feeling of danger, as if reality itself had been disrupted. Then, reports came in of strange events, equipment breaking, strange readings, and scary dreams. Fear gripped the scientists, leaving them unsure of what to do. Even though they were experts, they couldn't explain the mystery. Ideas became chaotic, and it felt like things were falling apart. It was like the unknown was causing chaos, leaving CERN to deal with something they couldn't understand. Afterward, unanswered questions remained, troubling the scientific community with the realization that some things might never be figured out. What mysterious force could be lurking within CERN's depths, challenging the very boundaries of science? Let us know your answer in the comments section. Balancing discovery and public concerns. In the vast realm of high-energy physics, especially at places like the Large Hadron Collider LHC located at CERN, the balance between groundbreaking discoveries and public worries is quite delicate. The tremendous energy levels reached during particle collisions at the LHC have sparked not only excitement and curiosity, but also ethical and safety concerns among both the public and the scientific community. How does CERN address these worries, and what measures are in place to ensure global safety while delving into the universe's deepest secrets? One major concern revolves around the theoretical possibility of creating micro-black holes at the LHC. These tiny black holes, if formed, would, according to theory, evaporate almost immediately due to Hawking radiation, named after physicist Stephen Hawking. Despite these reassuring predictions, the idea of generating black holes on Earth has stirred sensational headlines and public fears. In response, CERN has undertaken extensive safety evaluations and consultations with leading physicists to anticipate and mitigate any potential risks. Studies suggest that any micro-black holes produced would vanish quickly without causing harm. Moreover, CERN is committed to transparency and open communication with the public regarding the purpose, benefits, and risks associated with high-energy particle physics experiments. This dedication is evident through various public outreach and educational programs aimed at demystifying CERN's work and explaining its potential impacts. Additionally, the organization adheres to strict international safety standards and undergoes continuous scrutiny by a global community of scientists and safety experts. Beyond hypothetical risks, there are genuine ethical considerations in particle physics research. Debates revolve around the environmental impact of operating such a massive facility, the cost-benefit analysis of high-energy physics research, and the prioritization of scientific endeavors. CERN addresses these concerns by ensuring that its experiments are not only scientifically justified, but also ethically and environmentally sound. The organization conducts environmental impact assessments and seeks ways to minimize energy use and waste. The influence of the Large Hadron Collider at CERN stretches far beyond the realm of particle physics, impacting various fields of science and technology. Discoveries made at the LHC have the potential to revolutionize our understanding of the universe and pave the way for technological advancements that can enhance everyday life. For example, the World Wide Web, indispensable for global communication, originated at CERN in 1989. Technologies developed for building and operating the LHC, such as superconducting magnets and vacuum technologies, have found applications in medical imaging and treatment. Particle accelerators have led to innovations in cancer therapy, particularly through proton beam therapy, which enables precise targeting of tumors while minimizing damage to surrounding healthy tissues. Furthermore, the immense data processing capabilities developed at CERN have propelled advances in distributed computing, benefiting fields from climate research to genetic sequencing. Looking ahead, CERN continues to push the boundaries of scientific knowledge with plans for new experiments and facilities. The proposed Future Circular Collider FCC, a successor to the LHC, aims to delve even deeper into the mysteries of the universe. With a circumference of about 100 kilometers, the FCC would reach energies orders of magnitude higher than those achieved by the LHC, offering possibilities for discovering new particles, investigating dark matter properties, and potentially unraveling the nature of gravity itself. What are your thoughts on what has just happened at CERN that no one can explain? Let us know your thoughts in the comments below.